In this video, we will discuss about adding spaces to a string. You are given a zero-index string S and a zero-indexed integer array spaces that describes the indices in the original string where spaces will be added. Each space should be inserted before the character at the given index. Return the modified string after the spaces have been added. So what they are saying is that in the input, we are given a zero-indexed integer array spaces and a zero-indexed string S. What we need to do is that at all of these indexes inside this string S, we need to insert a space. For example, here we are given 1. So then that means at this position 1, just before this character, we need to insert a space. And after inserting spaces at all these indexes, we need to return the modified string. Right. So what we can do is that we can maintain two pointers, right? One pointer for the string S, let's denote it with I, and another pointer for the spaces array, let's name it J, right? So initially both of them will be 0, and then we can create a resulting string which will be initially empty, and in this resulting string we can append our characters one by one along with the spaces whenever needed. Right. So initially your index is 0. Now you will have to compare this index with this particular element from the spaces array which you are considering right now. Right. So this index 0 is not equals to 1. Then that means we can simply insert this or append this character in our string result. Right. So we will append I over here. And this I will be incremented to 1. Now this index 1 has become equals to this element. So then that means now we need to insert a space in our string. So here we will insert our space, and after inserting space we will append this character, right? So it will be after space. Then I will also be incremented and J will also be incremented, right? Again we will compare this 2 with the value 5. So these are not equal. So we can directly append this character. So we'll append O over here. Then I will be incremented to 3. 3 is not equals to 5. So character will be appended. I will become 4. 4 is not equals to 5. E will be appended. I will become 5. Now you will see that 5 has become equals to 5. So now we need to insert a space. So we will append a space here and we will append the character also. So I will come here. This I will become 6 and J will become 2 now. Now this 6 is not equals to 7. So we should append the character as is. So N will come here. I will become 7. Now this 7 has become equals to this 7, right? So then that means again we need to insert a space. So we'll insert a space here and then we will append this character, right? So P will come here. Now I will become 8 and J will become 3. Now this 8 is not equals to 9. So then that means we should directly append this character. So Y will be appended here. I will become 9. Now this 9 has become equals to 9. So we should insert a space. So we will insert a space here and then we will insert this character. So T will come after the space. I will become 10, J will become 4. Now we are done with the spaces array, right? J is out of the indexes now. So we can directly append all of these characters. So H will come, then O will come, and then N will come. And at the end, the value of I would be 13 and we would stop here. And this would be our resulting string and we can directly return it as our answer, right? So here we would be looping inside our string S, right? And inside that, whenever we are encountering an index which is present in this spaces array, we are appending a space into our resultant string, right? So our loop would be kind of running order of n plus m times. N for the number of characters in the string and m for the number of elements in the spaces array, right? And also for this resultant string, what we can do is that we know that what is going to be the size of our result string. What will be its size? The size of string S plus the size of spaces array, right? That will be going to be the size of our resultant string. So we can reserve that much size for this resultant string. So what will happen is that when we will be appending the character and space to the resultant string, then it will be performed efficiently in constant time. So the overall time complexity of our code will be order of n plus m, right? So let's quickly look at the code. So first of all, we will create our resultant string and we will allocate space to it. We will reserve space in this string. So we will use res.reserve. And how much space we need to reserve? S.size plus spaces.size, right? Then we will take 2 pointers I and j. So into j equals to 0 for the spaces vector. And then we will iterate inside the string s. So int I equals to 0, I less than s.size and I plus plus. right? Now inside this, we will check that if j is less than spaces dot size. We saw in the explanation, right, that the j crossed the indexes of spaces. So we need to check whether j is still within the indexes of spaces or not. So if it is, then we need to check that I should be equals to spaces of j, right? If these are equal, then that means at this particular position, we need to append a space into our string, right? So inside the resultant string, we will add a space. And since we have added a space, we should also increase our j by 1, right? And at every point, we would also be appending the current character into our string, right? So res plus equals to s of I, right? And at the end, we can simply return our result. So let's quickly run this. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.